Hello and welcome back to the Quality Excellence channel. I'm Mayank Agarwal, and in today's Lean Six Sigma training, we're covering Chapter 22, Sample Size. Today, we're diving into Six Sigma, a powerful and versatile methodology used across countless industries to make things better, more efficient, and more reliable. It's all about continuous improvement and data-driven decisions. From the complex engineering of rockets, ensuring every component meets the highest standards of precision and reliability, to the seemingly simple act of perfecting recipes in a kitchen, where consistency and quality are key to customer satisfaction. But to improve anything, to truly understand what's working and what's not, you need good data. Data that's accurate, relevant, and representative of the whole picture. And that's precisely where the concept of sample size comes in. It's a critical element in ensuring the validity and reliability of your data analysis. Think of it as your superpower for smart decisions. A tool that empowers you to make informed choices with confidence. It's all about understanding a whole population, a vast and complex group, by studying just a carefully selected small part. This allows us to draw conclusions and make predictions about the entire group without having to examine every single member. Now you might be wondering, why not just look at everything? Why bother with sampling at all? Well, the simple answer is, it's usually impossible. In most real-world scenarios, examining every single item or individual is simply not feasible. Imagine, for instance, testing every single light bulb produced in a factory to ensure it meets quality standards. If you tested them all to destruction, you'd quickly find you have none left to sell. Your entire inventory would be gone. That's precisely why we sample. It's a practical and efficient way to gather information without depleting resources or disrupting operations. It saves valuable time, reduces costs significantly, and ultimately makes the impossible possible. It allows us to gain insights and make informed decisions, even when dealing with large and complex populations. But here's the key. It all hinges on choosing the right number of items to check, carefully determining your sample size. Get it right, and you're building your analysis and decisions on a solid foundation, ensuring accuracy and reliability. Get it wrong, however, and your conclusions, no matter how well-intentioned, could crumble under scrutiny. A proper sample size gives you the confidence to stand behind your findings, knowing that they are based on sound data and rigorous analysis. It assures you that your small group, your sample, accurately reflects the big picture, the entire population you're trying to understand. This concept is at the very heart of statistics and the scientific method, providing the framework for drawing meaningful conclusions from data. Today, we'll explore in detail why choosing too small a sample can lead to misleading results and inaccurate conclusions, potentially derailing your entire project. Conversely, we'll also examine why selecting too large a sample can be an inefficient use of resources, wasting time, money, and effort without providing significantly better insights. We'll break down the essential ingredients, the key factors that go into determining the perfect sample size for your specific needs. We'll discuss when it's crucial to calculate it, ensuring you're making informed decisions from the outset. And of course, we'll explore how modern technology and readily available tools can greatly simplify the process, making sample size calculation more accessible than ever before. By the end of this exploration, you'll see that sample size isn't just a random number or an abstract statistical concept. It's a powerful tool that empowers you to see the world more clearly, make better decisions, and ultimately contribute to positive change. So, with that in mind, let's dive right in and get started on this exciting journey into the world of sample size. Remember Goldilocks? The classic tale of finding what's just right resonates even in the world of data and statistics. She wanted things just right. Not too hot, not too cold, not too hard, not too soft. She was searching for that perfect balance. That's exactly how you should think about sample size. It's not about arbitrarily picking a number. It's about finding the sweet spot that gives you meaningful insights. Too small a sample? What happens when you don't gather enough information? Imagine flipping a coin 3 times and getting all heads. It seems statistically improbable. You might think the coin is rigged, but you just didn't collect enough data. A small number of trials can lead to misleading conclusions. Small samples can miss problems or opportunities, leading to inaccurate assessments and potentially flawed decisions, like judging a movie by its first 30 seconds. You wouldn't get a true sense of the plot, characters, or overall quality. In Six Sigma, a small sample might hide a serious defect, a critical flaw that could impact product performance or customer satisfaction. leading to costly mistakes. These mistakes can range from product recalls to damaged reputations. On the flip side, is there such a thing as too much data? Can you actually have too many samples? Absolutely. Oversampling can be just as problematic as undersampling. Testing too many products wastes time, money, and resources, diverting them from other important areas, like smashing dozens of phones just to test durability. At some point, the additional data provides diminishing returns. The goal is efficiency. We want to gather enough data to make informed decisions without going overboard. Enough data for reliable decisions, decisions you can stand behind with confidence. But not so much that you're wasting effort. It's about finding that balance between thoroughness and practicality. The sweet spot? That Goldilocks zone of sample size? A sample size large enough for confidence, ensuring your statistical analysis is robust and meaningful, small enough to be practical, a manageable size that fits within your resources and timeline. Finding this balance is a key skill in quality improvement and research. It's a skill that separates good analysis from great analysis. It ensures your conclusions are sound, based on solid evidence and rigorous analysis, without breaking the bank. Because effective research doesn't have to be expensive research. Get it right, and you're a smart, effective scientist. Someone who understands the power and limitations of data. That's the Six Sigma way. A data-driven approach to problem-solving and process improvement. Don't guess, measure wisely. Let the data guide your decisions, but always with a critical eye. Choose your sample size with care. It's a strategic decision that can have a significant impact on your results. That's how you make data work for you, by understanding its nuances and using it responsibly. When embarking on any data-driven project, one of the most crucial decisions you'll make is determining the appropriate sample size. Too small, and your results might be meaningless. Too large, and you've wasted valuable time and resources. To find that just right sample size, you need 4 key ingredients. Think of it like baking a cake. Each ingredient plays a vital role in the final outcome. First, confidence level. This is the degree to which you can be certain that your results accurately reflect the true population. How sure do you want to be that your findings are not just due to random chance? 95% is common. The higher your confidence, the bigger your sample needs to be. A higher confidence level demands a larger sample size to minimize the risk of error. Second, margin of error. This defines the acceptable range of uncertainty in your results. How much wiggle room can you accept between your sample results and the actual population value? A smaller margin, meaning greater precision, requires a bigger sample. The tighter you want that range, the more data you'll need to collect. Third, standard deviation. This is a measure of the variability within your population. This measures how spread out your data is around the average. A low standard deviation indicates data points are clustered closely, while a high standard deviation means they are more scattered. More variation means you need a larger sample to accurately represent the entire population. Fourth, effect size. This refers to the magnitude of the difference or relationship you're trying to detect. Are you looking for a big, obvious change that jumps right out at you? Or a tiny, subtle one that requires careful examination to uncover? Smaller effects, those subtle nuances, require more data to detect them reliably. For example, if you want to spot a tiny improvement in a manufacturing process, something almost imperceptible, you'll need significantly more samples than if you're looking for a dramatic change, like a complete overhaul that doubles production. These 4 factors work together in a delicate balance. Change one, and your sample size shifts accordingly. It's a balancing act between precision, the level of accuracy you need, effort, the resources you're willing to invest, and what matters most for your project's objectives and business priorities. Understanding these ingredients empowers you to calculate the perfect sample size, ensuring your results are both meaningful and efficient. Don't just guess. Plan with purpose and a clear understanding of these key elements. The right sample size is your recipe for reliable results, giving you the confidence to make informed decisions. Get these ingredients right, and your conclusions will be rock solid, built on a foundation of sound statistical principles. That's how science and Six Sigma move forward, driving progress through data-driven insights. Ready to mix your recipe? Let's see when to use it and how these principles apply in practice. Timing matters. Always calculate your sample size before collecting data. It's like checking a map before a road trip. Plan first, then act. This step is crucial for experiments, A/B tests, surveys, and process improvements. Without it, you risk wasting time or missing key discoveries. Whether you're polling customers or running a scientific test, sample size calculation sets you up for success. Remember, calculate first, then collect. Let's talk about statistical power, the chance your study will detect a real effect if it exists. Low power is like searching in the dark. With a dim flashlight, you might miss something important. Most fields aim for 80% power. Why? It's a smart balance, high enough to catch real effects, but not so high that you need endless data. Too little power and you risk missing breakthroughs or making costly mistakes. The easiest way to boost power? Increase your sample size. More data means a brighter flashlight for your study. Other factors matter too, but sample size is the one you control most. Calculate the right size for 80% power before you start. That's how you set your project up for real discovery. Be a data superhero. Aim for 80%. Worried about complex math? Don't be. Modern software does the heavy lifting for sample size calculations. Just enter your confidence level, margin of error, standard deviation, and effect size. Tools like Minitab, JMP, or free online calculators make it easy. The software instantly tells you the minimum sample size you need. You can even play with the numbers to see how changes affect your sample size. This helps you balance certainty with practical limits like time and budget. Using software isn't cheating, it's smart science. Focus on your project, not the math. Let technology help you make the best decisions. Not all sample size calculations are the same. Different questions need different approaches. For continuous data like time or weight, use calculations for means. For yes/no data, like defect rates, use calculations for proportions. Building predictive models? Use regression sample size calculations. Running experiments with multiple factors? That's where design of experiments, DOE, comes in. Each scenario has its own method, but software guides you through the right one. The key: match your calculation to your data and your goal. That's how you get results you can trust. Let's put it all together with a tasty example. You manage pizza power and want to prove your new oven bakes pizzas faster than the old one. You want 95% confidence, a margin of error of 0.5 minutes, and estimate a standard deviation of 1.5 minutes. The effect size you care about? A 3-minute improvement. Plug these into your software and it tells you, bake and time 35 pizzas. That's enough for reliable results. No need to bake hundreds. You run the test and the average time is 11.8 minutes. With your sample size, you're 95% confident the true average is between 11.3 and 12.3 minutes, well below the old oven's 15. Your data proves the new oven is faster. Thanks to careful planning, you make a smart, data-driven decision. That's the power of sample size in action. What have we learned? The right sample size is your best friend for smart decisions. It helps you avoid being misled by too little data or wasting resources on too much. Remember the 4 key ingredients: confidence level, margin of error, standard deviation, and effect size. Plan ahead. Don't just collect data blindly. Aim for 80% power to catch real effects. Use software to make calculations easy and accurate. Match your method to your data and your question. Mastering sample size moves you from guessing to knowing. It's a skill that makes your projects more successful and your decisions more impactful. So, next time you start a project, calculate your sample size first and unlock the true power of data.